Your focus question for today is how do I name points, lines, and planes? How do I name points, lines, and planes? And what we're gonna go through some terms today, and we're gonna define the terms, and then we're gonna talk about how you name those terms, kind of in geometry language. So a point. A point is a location. And it's named by a capital letter. A point. It's a location named by a capital letter. So this is point B. If you had two lines, and you were asked where those two lines intersected, your answer would be point Y. They intersect at point Y. And that's supposed to be uppercase. I apologize. Point Y. A line. Straight path. It's a straight path that extends forever. In both directions. It is named by 2 points on the line or 1 lowercase script. Straight path extends forever in both directions. You name it by 2 points on the line or 1 lowercase script. So we got a line. One way to name this line. This little symbol here, I'll put it up a little higher. Line AB. What else could we call it? How else? Yes?
Line AC.
Line AC. Very good. What else? Line. BC. Very good. What else? 2 points on the line, or go ahead. Line M. Very good. And it would be line M. All those names are referring to the same line. 2 points on the line or one lowercase script. Doesn't matter which ones you use as long as you use 2 points that are on the line. Because in all these cases, we're still talking about that line that's on the wall.
Also, what could be the topic for our notes?
The topic for your notes is basically the focus question. How do I, naming points, lines, and planes. Let's talk about the term collinear. Collinear. What does linear mean? Linear means a line, doesn't it? So collinear means on the same line. On the same line, collinear. It's typically referring to points that are on the same line. So if you're given a line, and you're asked to name 3 collinear points. Someone volunteer, please. 3 collinear points. Go.
On the same lines, would it be like A and B?
It would be A, B, and D. Those are all collinear, aren't they? Well, I asked for 3 collinear points. 3 collinear points. So these would be collinear. If I asked for 3 non-collinear points, 3 non-collinear points, that's 3 points that are not on the same line. Go ahead.
C, E, and D.
C, E, and D, good. C, E, and D. Non-collinear.
But D is on the line. But it's not. That's not a collinear group. Like, you're not all together.
Collinear means on the same line. C, E, and D. Are C, E, and D on the same line?
It's on a line, but it's on the same line.
Are C, E, and D on the same line?
No.
No, so they're non-collinear. B, C, D. Collinear or non-collinear? 3 points. They're not on the same line, so those are non-collinear. Clear? Anybody confused? Yes, I understand that 2 of them are on the same line, but by definition, they're not all on the same line, are they? Okay. They all have to be on the same line to be collinear. A plane. That's a flat surface that extends forever. In all directions. That is a bad storm.
Why is the car going on?
Because it shake, rattled, and rolled enough to set the alarm off.
I wonder how long it's going to go on.
Probably for a while. Flat surface that extends forever in all directions. The front wall is an example of a plane. Okay? The ceiling. Example of a plane. Somebody give me another example of a plane in this room. The top of the desk. Very good. What else? This piece of paper that you just held up in front of you. All right. The floor. The door.
Could a binder be on? Like the top of it?
Top of the binder is a plane. Yes, it is. Okay. When you're referring to a plane in geometry, make sure that you can visualize it extending forever in all directions. Okay? Diagram of a plane. Let me go down here real quick and say named by an uppercase. Hello?
Hi, could you please send a little girl to the front desk for a second, please?
Yes, ma'am.
Thank you.
Named by an uppercase script letter or 3 non-collinear points. Named by an uppercase script letter or 3 non-collinear points. So back to this diagram of a plane. Here's our uppercase script. It'll usually be up in a corner or down in a corner. It won't have a point next to it. It'll be just a letter sitting by itself. Uppercase script. So there's a couple ways to name this plane. Anybody want to try one of the ways? Go ahead.
Me?
Yeah.
Oh, okay. You can name it ACD
You could name it plane ACD, couldn't you? Or Katie?
plain R.
Plane R. Okay? Plane ACD, or you can call it plane R.
It can be named by both.
Correct.
Like they'll all be there at the same time.
Well, you could be asked to name a multiple choice question might be something like, what are 2 ways to name the given plane? It could be plane R.
So it always has a script number and the linear points. Or
Yeah. It may not. I mean, it may have this. It may have a D, or maybe that's a P, and this is an F, and this isn't here at all.
Oh yeah.
So now, one way would be plane ACD.
Right.
Another way would be plane CDF. Another way would be plane ACF. 3 points, not on the same line. Obviously, they have to be in the plane. All right, you cannot call it plane ACB. B is not part of this plane. It's not in the diagram, is it?
Oh, okay. So that's weird.
Yeah, they got to be in the plane, but not on the same line. Clear? Okay, so if collinear meant on the same line, then what do you think coplanar means?
On the same plane.
Very good, on the same plane. Coplanar, on the same plane. You'll also hear it as in the same plane. Non-coplanar, not in the same plane. All right, so if you go back to a diagram, 3 coplanar points, point A, C, D. 3 non-coplanar points, points A, C, B. Okay? Coplanar, they're all in the same plane. Non-coplanar, they're not all in the same plane. Segment. That's a part of a line containing 2 endpoints. Part of a line containing 2 endpoints. It is named by its endpoints. There's a bunch of segments in this drawing, isn't there? Someone name one segment in this diagram. Go. Segment
It's AD, right?
AB.
I thought it was second.
Well, segment AB has endpoints at points A and points B. Do you notice the symbol over the AB, how it's different from line AB?
So the point is considered an endpoint.
Correct.
You don't mean like that.
There's another segment in this diagram. What is it? Segment? Segment CD. What's another segment in here? B to C. There's another segment in here. AD. And there's one more. A to C. Good.
Could it ever go backwards?
What you're going to see is when you look at your answers in the back of the book, they're typically going to be in alphabetical order.
Okay.
But segment AB and segment BA are the same thing, aren't they?
Yes.
Segment BA is not wrong. All right. You know, if you're asked to
But
name,
you can't like put it as two separate things. When it's the same.
it's the same thing. If you call it BA and the book calls it AB, you're not wrong. Okay? So segments, that's how you name them, by their endpoints. A few more definitions, and then I got a study guide for you for tomorrow. We're going to talk about array. That's a part of a line. Part of a line that starts at an endpoint and extends in one direction forever. Ray. AB. Here's its endpoint. It extends through B forever. Named by its endpoint and another point on the ray. Everybody okay with that? So we name this, watch the symbol, ray AB. Ray AB starts right here at A. It goes through B in that direction forever. Questions? Yes?
What if there is no endpoint?
It's real hard to name it. You mean if you had
Just A.
it's hard to name that. If you're asked to name a ray, they're going to have to give you another letter, another point on the ray. Finally, opposite rays. Opposite rays. Obviously, they go in opposite directions of one another. They have a common endpoint. And form a line. They have a common endpoint and they form a line. Any volunteers want to give me a pair of opposite rays? Pair of opposite rays. Yes.
BC.
I need two rays that have a common endpoint and form a line. Yes.
Oh.
Well, remember that we name a ray with an endpoint and another point that it goes through. AC and AC starts at A, goes through C to the right. DC starts at D, goes through C to the left. Common endpoint. Remember that a ray starts at its endpoint. Can anybody see them yet? Is there a ray that starts at C and goes through D? Good. Is there a ray that starts at C and goes through A? Good. Do those two form a line? Yes. Do they both start at C? So do they both have a common endpoint and form a line? Look, red. Red starts at C, goes through D, doesn't it? Ray, CD. Blue starts at C, goes through A. Ray, CA. Do they meet the criteria of the definition? Do they have a common endpoint?
It
Ju-
starts at C, so how's it gonna end?
Array starts at its endpoint.
Oh, yeah.
By definition, like, it's very confusing. Array starts at its end. Array starts at its endpoint. Remember? Go back. Named by. Oh, let's see. Where was the definition of array? It was right. Where's my hand? Right. Oh, there's array. Part of a line that starts at an endpoint. So opposite rays start at the same end. And they go away from each other forever, but they form a straight line.
Yep.
Is ray CB an opposite ray of CA? But they have the same endpoint.
They're not forming a straight line.
They don't form a line. Very good. Okay. Ray CB and ray CA are not opposite rays. They do have a common endpoint, but they do not form a line. All right? All right, you're going to complete your notes now by answering the focus question. You're going to answer the focus question in 2 or 3 complete sentences. And then you're going to work on the study guide that I am